There's really not much to say in exercise 5B. It's just about gradients of lines or intervals. It's really just a review of what you've done previously. I guess there is the application of gradient, and like I said in the introduction to this whole chapter, that's really important, that you realise you could get questions where there's no reference to gradient, though you have to know to use the gradient formula or to be pursuing the gradient calculation to be able to answer the question. So I just encourage you then to read through the notes slowly, highlight significant points. For example, all of these sorts of things here I'm sure you already know, but maybe this diagram is a diagram that you could modify to put into a summary. So you know the formula for calculating the gradient between 2 points, and I've closed the reference sheet now, but I'll be very surprised if that's not on the reference sheet. So if you got a question that was talking about the slope of a line, you've come across that many times before, so that's nothing new. You would know that if you read the word slope, you would make the connection to gradient on the calculation. Rate of change, now that might be something that you're not familiar with a lot, but you will become very familiar. We do a lot about rates of change, and we are talking specifically about gradient, but you're not going to see gradient calculated using this formula as much as another formula that also gets the gradient. But for now, if you see a rate of change, then this is the only formula you have, so you would use it. Things like testing whether points are collinear. Now that's fairly random, isn't it? Collinear. What's collinear got to do with gradient? But if you think about it, points will only be collinear. So these 3 points are not collinear. Collinear means existing on the same straight line. These 3 points are not collinear. However, these 3 points look fairly well like they would be collinear. They sit on the same line. So if this is point 1, point 2 and point 3, if I found the gradient between these two, then I use this one again. So I'm definitely going through this point, and I find the gradient between that and the next one, and I find that they have the same gradient, then they have to be collinear. There is no other option. So just be aware that a question could have the wording about, or could be asking you to find if points are collinear, and you need to make a connection to the gradient between 2 points. The angle the interval makes with the positive x-axis is also the gradient, and the gradient in the form of rise over run, which is the tan of the angle, and you'll come across that. And certainly these are really common. Parallel. Anytime a question is talking about parallel, immediately think gradient, because parallel lines have the same gradient. Perpendicular, then the product of the gradients is -1, or the gradient of one is minus the reciprocal of the gradient of the other. So yeah, there are some ideas there in that diagram that might be good as part of a summary. And then you can just see I've worked all the examples. Here's this idea about gradient and the tangent of a line, and that's important. And yeah, I think you should be right. Please take your time and go through that. Don't flick through it like I did. Please slow it down, take your time, work through the examples, check your answers are the same as mine, and work through 5B.